Hey there, and welcome. Today, we're going to unlock one of my absolute favorite algebraic tricks, factoring by grouping. Think of it as the secret key for those super tricky polynomials that just don't want to play by the normal rules.
So let's get right into it. You've probably mastered factoring out the greatest common factor. You're a whiz with trinomials, but then you hit a wall. A polynomial with 4 terms. What do you even do with that? Well, that's the exact puzzle we're going to solve together today. Take a look at this guy. X cubed plus 3x squared plus 2x plus 6. See? 4 terms. Your usual bag of tricks just won't cut it here. So, what's the plan?
Here is our roadmap. First, we'll break down the puzzle and the strategy behind it. Then, we'll get our hands dirty with a few examples. After that, I'll show you the common traps and how to avoid them. And finally, we'll talk about why any of this actually matters in the real world. Sound good? Let's do it.
Okay, first up, the puzzle and the strategy. It's time to pull back the curtain on these 4-term polynomials.
The official name for our secret key is factoring by grouping. And honestly, the core idea is pretty straightforward. We're just going to split the problem in half into 2 little groups. We'll factor each of those groups on their own. And then, and this is the really cool part, we find a common piece between them and pull it out. It sounds a little complicated, I know, but trust me, it's actually super elegant once you see it.
And here it is, the whole process in 4 simple steps. Think of it like a little dance. Step 1, you group the terms into 2 pairs. Step 2, you factor out the greatest common factor, the GCF, from each pair. Step 3 is the magic moment. You check if the little expressions left in the parentheses match. If they do, you're golden, and you can move to step 4, factor out that matching piece. Let's see how this dance actually looks.
All right, on to section 2, examples in action. Enough talk, let's put these steps to the test.
We're going to start with the exact same problem from the beginning. X cubed plus 3x squared plus 2x plus 6. Let's break this down together.
Step 1, group them up. All you do is put parentheses around the first 2 terms and another set around the last 2 terms. Seriously, that's it for step 1.
Now for step 2, and this is where the fun begins. In that first group, x cubed plus 3x squared, what's the biggest thing they share? It's x squared. So we pull that out front, and it leaves us with x plus 3. Okay, now the second group, 2x plus 6, their GCF is 2. We pull that out, and would you look at that? We're left with x plus 3 again. They match. That's the signal. That's how we know this is working.
So here's the payoff. Since both halves of our expression have that x plus 3 in them, we can factor that whole piece out. And what are we left with? The x squared from the first part and the plus 2 from the second. We just scoop those up into their own parentheses, and boom, the final answer, x plus 3 times x squared plus 2. Just beautiful. Okay, you ready to level up a little? Our next example has a really common twist. We've got to deal with some negatives. Let's take a look at 2x cubed plus 4x squared minus 3x minus 6.
Okay, we group it and we factor the GCFs. The first group's easy enough. We pull out a 2x squared and we're left with x plus 2. But now look closely at that second group, minus 3x minus 6. If we just pull out a 3, we'd be left with negative x minus 2. That doesn't match. So here's the pro move. We factor out a negative 3 instead, and by doing that, it flips the signs inside, giving us a perfect match, x plus 2.
And once we have that match, it's the same final step as before. We pull out that common x plus 2, and what's left behind is 2x squared minus 3. And there's our final factored form.
All right, time for the advanced round. What on earth do you do when the terms aren't in a helpful order to begin with? Check this one out. 6x squared plus 3y minus 2xy minus 9x. If we try to group this as it is, well, it's a mess. The first pair has nothing in common.
So what do? We rearrange. The whole goal is just to pair up terms that actually have something in common. It makes a lot more sense to put the 6x squared with the minus 9x, right? They both have an x and a factor of 3. That leaves the other two, minus 2xy and plus 3y, which both share a y. Now we've got something to work with.
So now we can factor our new groups. From the first one, we pull out a 3x, leaving us with 2x minus 3. For the second group, we got to watch those signs again. We'll pull out a negative y, and that leaves us with a matching 2x minus 3. Perfect.
And the final step from here, it's a piece of cake. Factor out that common 2x minus 3, and our answer is 2x minus 3 times 3x minus y. Done.
You know,
knowing the steps is one thing, but knowing how to fix things when they go wrong, that's what turns you into a pro. So let's talk about the most common mistakes and how you can sidestep them completely.
Oh man, this is the big one. It's so frustrating. You do all the work, and you end up with something like x plus 2 in one part and x minus 2 in the other. They are so close, but they don't match. The solution is almost always to go back and look at your second group. Did you need to factor out a negative to flip those signs? I'm telling you, 9 times out of 10, that's the fix.
So let's just nail down these 2 pro tips. First, always watch your signs. Factoring out a negative is one of the most powerful tools in your toolbox. And second, do not be afraid to rearrange the terms. If your first attempt at grouping just isn't working, shuffle the deck and try a new pairing. The right combination is probably just hiding in there.
Okay, so we've spent a lot of time on the how. Now let's talk for a minute about the why. Why on earth does this matter once you're done with your algebra class?
Well, this isn't just some abstract puzzle for a textbook. In the real world, an engineer might need to figure out the critical stress points on a beam to make sure a bridge is safe. And those critical points, they're often hidden inside really complex polynomial equations. To find them, engineers have to break those equations down into simpler parts. And factoring by grouping is a fundamental tool they use to get it done.
And that's really the big idea here, isn't it? Taking a big, messy problem, breaking it into smaller, manageable groups, and then finding a common link between them? That's not just a math trick, that's a life strategy. So I'll leave you with this thought. What other complex problems in your work or just in your life could you solve if you just thought about grouping the pieces a little bit differently? Something to think about. Thanks for tuning in.